Have you ever wondered how plastic, the stuff that's just about everywhere, is made? Yes, my friends, plastic, that sneaky chameleon of a material that seems to have an uncanny ability to transform itself into just about anything. From the humble toothbrush that wakes us up each morning to the computer keyboard that tirelessly records our thoughts and ideas, plastic is as versatile as it is omnipresent. Now pause for a moment and imagine your day without plastic. Quite a challenge, isn't it? It's as if our daily routines are choreographed by this ever-present material. From the moment we rise from our plastic-framed beds to the second we switch off our plastic-encased phones at night, it's there, silently playing a part in our everyday lives. What's more, it's not just the everyday items. Plastic also stars in some of our most cherished moments. Remember that first sip of coffee from your favorite plastic travel mug? Or that triumphant high five with your best friend, both of you wearing plastic gloves, after completing that epic DIY project? Yes, plastic is there, etching itself into our memories. But have you ever stopped to ponder how this marvel of modern life is made? How do we go from a handful of raw materials to a myriad of items that are as diverse as they are essential? What's the secret recipe that takes us from the crude beginnings to the polished final product? Well, it's not magic, although the process might seem like it at times. It's a fascinating journey of transformation that involves science, ingenuity, and a dash of creativity. It's a story that's as intriguing as it is enlightening, one that's been unfolding for over a century and continues to evolve even today. So, are you ready to unravel the mystery? Are you prepared to delve into the hidden world of this ubiquitous material? Well, strap in, because we're about to embark on a journey to uncover the secret life of plastic. Our journey begins with the raw materials needed to produce plastic. Now you might be thinking, raw materials? Isn't plastic made in some sort of scientific lab? Well, yes and no. You see, plastic is actually derived from petroleum and natural gas, two naturally occurring substances deep within the earth. Imagine, if you will, rugged drillers bravely venturing into the bowels of the earth, extracting these precious resources. But it's not as simple as just pulling out a chunk of petroleum or a bottle of natural gas and saying, all right, let's make some plastic. No, it's a bit more complicated than that. You see, petroleum and natural gas are like a chocolate chip cookie. They're delicious, of course, but they're also made up of different ingredients. In the case of our resources, these ingredients are known as hydrocarbons, complex molecules made up of hydrogen and carbon. But to make plastic, we need to break these hydrocarbons down into something a bit simpler, something a bit more manageable. And just like how you might break a cookie into crumbs, we need to break these hydrocarbons into smaller molecules, which we call monomers. This process is known as cracking, and it's done in a refinery. The hydrocarbons are heated to very high temperatures, causing them to break apart. The result? Monomers, the building blocks of plastic. Now, monomers are like the single bricks that will eventually form a grand castle. In their simplest form, they're quite small and unimpressive. But when thousands, millions, billions of these monomers come together, they form something truly remarkable. So we've got our monomers. Now what? Time to get these babies to bond. Scene script. Welcome to the magic show, folks. Today's trick, turning monomers into polymers. Now, what on earth are monomers and polymers? Well, think of a monomer as a carriage in a train. It's a small unit, but when many of them link together, they form a long chain, much like a train. This long chain, my friends, is what we call a polymer. Let's dive a bit deeper. You see, our magical monomers are tiny molecules, and they have a special trick up their sleeve. They can join forces with their fellow monomers, linking arm in arm to create a much larger molecule, a polymer. This process is known as polymerization, and it's where the real magic happens. Imagine a magic spell that causes a single carriage to duplicate and connect to itself over and over again, until you have an extensive train. That's polymerization in a nutshell. Isn't that just a hoot? But how does this magic spell work? Well, it's all about bonding. When monomers bond together, they share electrons, forming a stable structure. This process is like a group of carriages linking up to form a train. Each carriage, or monomer, has a hook, or a bond, that allows it to connect with the next one. The result? A sturdy, long-lasting polymer train all set to embark on its journey. Does this happen in a flash, you ask? Not quite. It's a bit of a slow burn, much like a train chugging along and picking up carriages along the way. But the end result is worth the wait. A polymer, a molecule made up of repeating units, just like a long train made up of many carriages. Now you must be wondering why this magic is so important. Well, this polymerization process is the foundation of making plastic, our ubiquitous companion in the modern world. From the water bottle you drink from to the keyboard you're typing on, it's all thanks to the magic of polymerization. And voila, we have polymers, but we're not done yet. Next stop, Plastic City. Okay, we've got our polymers, but how do we turn these into the plastic stuff we use every day? A question of such magnitude, one might think we're about to reveal the secret to eternal youth. But fear not, it's just as magical. Welcome to the world of molding, the plastic's own fashion show, where polymers strut their stuff and transform into something fabulous. Picture this. A polymer is like a lazy cat on a Sunday afternoon, lounging around with no real shape or form. But when the cat sees a mouse, it leaps into action, taking on a sleek, streamlined form. Similarly, our polymers, when subjected to heat and pressure, leap into action, transforming from a shapeless mass into a variety of forms. This process is called molding, and it's a bit like baking a cake. You take your raw ingredients, in this case the polymers, and add a dash of heat and a sprinkle of pressure. Mix it all together, and voila, you have your plastic. There are a few different ways we can do this. There's injection molding, where the polymers are heated until they're a bit like thick soup, then squirted into a mold. It's a bit like using a piping bag to decorate a cake. Then there's blow molding. This is how we make things like bottles. It's like blowing up a balloon, but with hot, molten plastic instead. And finally, there's rotational molding. This is used for making large, hollow objects. It's like making a giant chocolate Easter egg. You pour the molten plastic into a mold, then rotate it around until the plastic coats the inside. Each method has its own unique charm, but they all follow the same basic principle. Heat the polymers, shape them under pressure, and let them cool. And just like that, we've got our plastic. But wait, there's more to this story. So, we've made our plastic, but what happens after we're done with it? Well, that's a question that carries a great deal of weight. You see, the convenience of plastic is undeniable. It's light, it's durable, it's versatile. We use it in everything from packaging to product manufacturing, from medical equipment to the tech gadgets we can't live without. But this convenience comes with a cost. Imagine you're out at sea. It's a beautiful day, the sun is shining, and you're surrounded by a vast expanse of blue. But then, you see it, a plastic bag, bobbing along with the current. Not so beautiful anymore, is it? Plastic, unfortunately, doesn't break down like organic materials do. It can take hundreds, even thousands of years for plastic to decompose. And during that time, it wreaks havoc on our environment. It clogs our waterways, harms wildlife, and contributes to pollution. And then there's the issue of plastic production. It's not just about what happens to plastic after we're done with it. The process of making plastic involves the release of harmful chemicals into the air. These chemicals can have detrimental effects on the environment and on human health. But it's not all doom and gloom. There are ways we can mitigate the impact of plastic. Recycling is a big one. By reusing plastic, we reduce the need for new plastic production and help keep plastic out of our oceans and landfills. Responsible disposal is another important step. Instead of tossing that plastic bottle out the car window, find a recycling bin. And let's not forget about reducing and reusing. Do we really need a new plastic bag every time we shop? Can we find ways to reuse the plastic items we already have? These small actions can make a big difference. So there you have it, folks. The life of plastic, from raw materials to your everyday items. Remember, with great plastic comes great responsibility.